Good afternoon. I'd like to introduce you to Dr. Ben Martin. He's been presenting for us before. I think it was an open document format.
Yes, yes.
And today he will present FileSender, which is the name actually says it, I think.
Yes.
So go for it.
Alrighty then. I said a fair bit in the abstract, but I thought I'd just repeat parts of it just to sort of clarify why a FileSender exists and why you should possibly be caring about that. I sort of had the same reaction that a lot of people have when I heard about it. I thought you've got HTTP and FTP and rsync and SSH. You know, I can set up a web server, I can send files to people. I don't really need yet another solution to do that. So with FileSender, basically you have a server, which is PHP or a database, and some of the advantages are that if I met someone at a conference and you have a file that I'm researching, or for whatever reason I would like to get a hold of a file that you were happy to share with me that's say 100 gig, you don't have a server set up, but I have a FileSender instance or access to it. I can invite you to send a file to me on my FileSender instance. I can just send you a link and you come on as a guest. I can restrict your access and say you can only send files to me, not to anyone else. So I don't know the person. You know, you might be wanting to upload something that's illegal and share it to other people through my server, but I can restrict you to only sending files that I can access. Yes, you can have anonymous FTP to set that up, but also then you don't get deletion, you don't get notifications if I send you a link. If you download it through FileSender, I will get an audit or a notification if I like an email saying, yes, that person's downloaded it at this time. So there's a lot of extra data that you get and the abilities to easily share files with other people. And one of the great use cases for FileSender is if you're sending a large attachment or a medium size or a small attachment that's like 50 or 100 meg and you want to email that to someone, you can be almost certain that their email server will say that attachment's too large. With FileSender, you can upload that, get a link to actually allow people to download it, and then email the link to the person. One of the main things with FileSender, one of the main use cases is that the data is not archived. There are some people who are disabling the deletion so that basically they're using it as a front end to upload to archives. But the default case is, you know, say 30 days. So I want to send an email to someone, I send them an email and it says you have 30 days to download this, otherwise it gets deleted. It gets deleted in 30 days if you've got it or not, sort of thing. So there's a lot of auditing, there's the ability to invite guests, and one of the other key points is end-to-end encryption. So if I meet you at the conference or whatever, I can write down something on a passphrase on a napkin, split the napkin in half, give you half, and say in a week's time you'll have a file, here's the passphrase. The actual distribution of the key or the passphrase is outside of FileSender. It lets you choose a key if you like, it lets you generate one, but it doesn't try to be everything to everyone. It doesn't say now we'll magically solve sending secrets around to people. But any of the encryption happens in your web browser and the decryption happens in the other person's web browser. So if you're using a FileSender instance that's offered by your research, your university or your work, the actual server side, nobody can get your information. Only people who have the password, and it's AES-256 encryption, so you need to have access to either a large amount of compute power or have the password. The FileSender is used in all of the countries highlighted in green. A few standouts in Europe, but hopefully world domination happens at some point. It's been around for quite some time. I joined the project about sort of 18 months ago. I'm now the lead developer / maintainer on the project, so everyone shouts at me and I sort of try and fix things. Most of the people in this graph, the green is actually countrywide because national research education networks use it. So in the Netherlands, SurfNet uses it, and SurfNet would offer that to whoever they're willing to offer it to, but usually in Australia's case, ARNet offers it, which is our equivalent to SurfNet, and they offer it to universities. So you go to a university and you've automatically got access to FileSender. So if you can log in, you can authenticate to their FileSender and you can start inviting people and sharing files. Yes, it does actually show. This is basically what the main interface to FileSender looks like. I realise that this part of it is sort of moderately ugly. There's plans to overhaul that and change the way passwords are set up, which I'll get to a little bit later on. But basically you can drag and drop one or more files or a directory into that main section, and it begins, when you click on the send button, begins sending that to the server with your optional encryption password, which is done client-side before it gets sent. Unlike some of the things, if you're sending a 5 terabyte file across, there's quite a high chance that that won't happen for whatever reason, like the networks just aren't that good, the HTTP link goes down, things get broken. FileSender has resume capability. The default configuration has 5 meg chunks. So when you resume, you only lose, depending on the exact configuration, because you can have multiple 5 meg chunks in flight, but you're only going to lose sort of multiples of 5 meg, and then it'll restart. So if you're halfway through, you come back and it says it failed, you say, okay, I'll resume that, and then you're halfway through that 1 terabyte upload again. You don't have to keep trying and trying to force that thing, which there are some things where you're uploading large videos or things like that to services, and basically every time it fails, you have to start again, which in this case, because it's designed from the ground up to send large files to people, there is resume, and you can come back again and resume later on. You don't have to sort of keep the web browser open and resume immediately. The server remembers that you were 50% of the way through, and you can touch off from there. Once you've done your upload, you get transferred over to My Transfers, which you can see the list, in this case, of sort of fairly trivial testing transfers, but you can see a log of things. Things that are closed at the bottom are no longer available. As I say, there's a rolling expiration in FileSender. And if you click on any one of them, you can see details about what sort of options were set, and an audit log, who's downloaded it, when they've downloaded it, how many times it's been downloaded, basically everything that's happened to that information. Then you can elect to delete it from there. Resend notifications to people. If they say they didn't get the email with the link to the file, you can say, that's great, I'll just click there and resend that email, and then say, did you get that second email? Otherwise, we have to sort of track that down. And as you can see in this case, there's a direct download link anyway, so if you wanted to, you could just copy and paste that or send it to someone. The main motivations for why you'd want to use it are that basically the whole interface from a user's point of view is a web browser. So if you've got Firefox, Chrome, any recent web browser, you should be able to log in and use, if you have authentication, to a FileSender service. So if you're setting one up for a small company or something with 20 to 100 people, basically, there's no overhead of trying to maintain software. Everyone can just sort of log in if they have credentials to do so. You have full control of content because it's PHP, and basically it's stored wherever you set the server up. If you want to set it up in the Netherlands, you do that. You're not sort of beholden to another cloud company for storage. Wherever they're going to do it or whatever, you're in control. The upload resume, I think, is a fairly big one. It seems like an obvious thing, but I've seen many video services and things like that where you're uploading large content and basically it just restarts. So being able to resume. The encryption is done in the browser, decryption is done in the browser on the other end, and AES 256. I've added options for GDPR compliance by default. So if you have things like files are being deleted after 60 days, there's an about page which tells the user explicitly, this is how long that data is retained, so that you don't have to sort of think about it. Whatever your configuration settings are get shown to the user, which makes it a little bit easier to sort of, let people know what's happening rather than, oh, here's FileSender, and they go, how long are you keeping that? How long do you keep records of this or that? It comes with the software telling people about that. So the hows, I get toward coding stuff at the end and encryption stuff, which I did sort of, I think, put in the abstract for the talk. So, that's at the end, and, hopefully I'll have enough details in there that you go away thinking FileSender might be interesting for my use case. The client side's JavaScript, the server side's PHP. There is sort of a move to go to PHP 7.0 at least by default. The database is Maria 10 or sort of any recent Postgres. There's aggregate statistics which need upserts, which I think 8.5. But you can disable aggregate statistics anyway. Postgres is fairly easy. MariaDB, I backtracked some of the features I added recently so that it did work on 10.0, and I had some people wanting to run it on MySQL 5.5, And to those people, I sort of say, don't do that. Like, you know, please, something semi-modern would be good. Web server can run with either Apache or NGIX. And you can use SAML if you have SAML set up where you are. At some of the open source conferences I've spoken to, they've sort of shied away and said, we don't really want to have to set up SAML. Like if you've got a large authentication server and 100,000 users, it's great. If you've got 100 people in a file server, you might just want to have PAM authentication or something lightweight. So you can have username passwords and not have, you know, large authentication servers to call out to. And SAML itself allows you to configure multiple backends, but I have found that the documentation is a little bit interesting in doing that. I've heard of people using it to authenticate with Active Directory, but I haven't created a config file to do that myself. So this part of it might actually be from a, you know, you don't have a large group of 100,000 people who want to actually race in and use it. Having a sort of more configurations for SAML for lower end, so that if you've got, yes, I like it, this company's got 200 people, or there's 200 people who I want to give access to this server, you can sort of maintain the username password database a little bit easier than playing around, I guess. I briefly mentioned that there's the chunks, which are sort of the minimum size unit that can be committed in FileSender. You can configure the size of chunks. By default, it's 5 meg. So if you are uploading and then the upload goes away for any of the number of reasons, you may lose 5 meg. Or if you have simultaneous upload of 5 chunks at once, you might lose 25 meg. You can actually up that to 100 meg or, you know, a larger size chunk, but at the expense of potentially losing a larger amount of your upload. The users really don't care about that, and the other aspect of chunks is that the web APIs slice in the various formats depending on if it's WebKit or whatever browser you happen to have. That's sort of the largest piece that you need to read from a file before you can start transmitting the data. So these days with SSDs, it sort of matters less. If you've got 5 meg and you're downloading 5 meg chunks, you can sort of read that from the disk fairly quickly. This is where the slides get quite interesting to try to select. Excellent. There's multiple ways. I'm hoping to simplify this over time. There's about 4 or 5 different paths in the code to upload. TerraSender's the main one that sort of is, you know, the focus of things, which uses web workers. So you've got threaded uploads in the background in the browser. So you can configure how many of those you want to have at once. One of the big gains, well, 2 of the gains, if you're uploading that way, if you're just using TCP connections using XHTML requests, there's going to be downtime, like because you do a blob slice, you say, here's your 5 meg data, and then it says, oh great, that's complete. And then there's going to be sort of time where it's doing another slice and the TCP stream's sort of torn down and it's, you know, there's wasted time. So if you have 5 of those going at once, the other streams can sort of mop up the bandwidth while other things are happening. And if you turn around and then say you want to have encryption in the browser, it takes a while to encrypt a 5 meg chunk. And so then while that's encrypting, the other 5 meg chunk is still uploading that was encrypted. So if you have 5 things in flight at once, then the network is really going to get, what bandwidth you have available is going to get saturated, in theory. And if you have more bandwidth, you can just have more chunks. So I really did hope that the slides would just work, but there we go. On the server side, you can either recalibrate the file into a single contiguous file. So if someone sends you a 1 terabyte file, there's a 1 terabyte file on your server, and if someone wants to download it, they have the one file. Sometimes that doesn't work out too well because you start getting file system fragmentation, so you can store the chunks directly as individual files, which is more useful because as they get deleted, you're reclaiming 5 meg chunks and then you're basically reallocating them again so that the fragmentation sort of reaches a plateau, I suppose. You can store with external scripts if you like, and RNet uses Ceph, so if you want to actually store it into a larger sort of, or again, if you want people to be able to upload to Ceph and you don't really want them, they don't care to want to know how to do that, you can configure your backend to be Ceph and then have the chunks to upload into Ceph and they just use the web browser. So if you have and moderately easy to add, there's cloud for Azure and S3, but if you have another back-end service that you want people to upload to and you want them to just be able to use the web browser to do that, and you don't necessarily think that they're going to be interested in, you know, XYZ service for storage, You could add a new storage backend and use FileSender to let them upload to whatever you're wanting them to upload to. Downloading, you need to grab the one or more files. There is on-the-fly zip64 compression. I'm hoping to add on-the-fly tar gzip, or well, not so much gzip, but tar. So basically on machines like this one or on a Linux machine, you can just download a tarball of everything if there's 5 files in the transfer. And especially now that there's directory support, so you can just say, drop a whole directory in there and have 10,000 files uploaded in one transfer. You may actually want to say, I just like those 10,000 files as a tar file or as a zip. You can get a zip currently, but tar file would be sort of more useful in some platforms. The fun part, if you were thinking about rolling your own, is that the more you look, the more you find. If you're uploading and you disable Wi-Fi on a laptop, nothing happens. Your XHTML requests continue to sort of try and do things and do nothing. There's no signal given to the browsers, across browsers, saying, oh, by the way, there's no routable network available at the moment. So those requests time out, and then they certainly time out on the server side, but then there's little interplays there. Maybe on some web browsers they don't time out, but they'll time out quicker on the server. So when you get network back, it'll try to actually reestablish those client connections, and the server will say, well, these ones have already expired. So you need to be able to handle things like the network going away, the client still thinking it's uploading, and the server knowing that it's already given up on those connections, and then automatically resume that. There's multiple phases of automatic resume. Chunks have a configurable amount of times that they'll try to re-upload once they've failed, and on top of that, it can actually restart the whole thing automatically. So the whole idea, in my mind, is if you have that screen and you say, I want this 1 terabyte file sent, and you click send, that's what you want to do. You want to come back the next day and it has a big green tick and says, yep, that's done. If it says that's done, but by the way, in that time period I had to retry it 20 times, you don't really care as long as it's done and the file's up there. So the send button should be sort of your last point, and then by the way, send me an email when it's done, or whatever. But you don't really want to have to say, oh, the network's had a bit of a dodgy moment at 3 a.m. and I'm only halfway through, I'll have to resume that upload. One of the interesting points that I found was that long uploads can actually exceed your SAML authentication session. So if you have a 24-hour window when you log in with your username and password, the upload can actually last longer than 24 hours because if the file's really large. So you need to be able to sort of say, hey, you've already been authenticated to upload this, I'll just keep you doing that. And the end-to-end encryption uses the Web Crypto API, which is W3C, and I think it's the 2017 version that I was looking at. Database design's reasonably simple if you were looking to dig into that from a back-end point of view. There are still some sort of things that could be cleaned up. If you are a SAML authenticated user, you're going to user preferences, and if you're an invited guest, there's a guest table, but there's no sort of contacts table, which you would think if you have a person entity, you'd have people. But you can have multiple files per transfer, and you can nominate recipients, which can be handy. But again, because one of the things with FileSender is that the user should be in control of their data and privacy, etc., you can upload and say, give me a link, and you don't then have any recipients. You're not sort of saying, oh, by the way, here's a list of 5 people I want you to email about this. You just say, give me a link, and I'll take care of that, and you don't get to know. Some recent things that I've been adding to the database were moving to the user preferences table. Used to sort of have the full authentication email that we're using to log in as the primary key, which is no longer the case. I've added a bunch of referential integrity, secondary indexes, and views, which again, the more you add, the more you discover that older databases that people tend to want to still use for whatever reason, like Maria 10.0, well, in that case, it doesn't support subselects in view definitions, so you need to sort of work around that. So it's interesting. The FileSender has its own object relation model between the PHP and the database side, which the easiest way not to have to upgrade your ORM is to actually build one into your project. So then you don't get all the upgrades because you have to make them yourself. It's not so bad, and There's things like being able to find all things, delete things, save things back to the database. There's I think it may or may not be in the next slide. There's also a migration script, so if you change things or add new fields into PHP classes, they get automatically updated in the database. I've added, prior to really getting into the views, I added a bunch of some functions to smooth over again the differences between MariaDB and Postgres. So in this case, there's no date diff in Postgres that there is in SQL Server and in MariaDB. So not only is the ORM loading the data into PHP objects for you and saving it back again, but there's ways of actually bringing the date diffs out so that code that would only work on one works on another. I think I'm doing reasonably okay for time. So the FileSender overview, there were two main areas of lower level detail. One's the overview of the FileSender code and how it operates to use web workers to upload stuff. And the other one is basically a little bit of a look at some of the encryption and how it's intended to be changed. So the FileSender uses a collection of web workers, and yes, the whole upload has an Asterix there because basically if there's already chunks in flight and you actually go navigate away from the page or whatever, or your machine goes to sleep and you come back again, you've lost maybe between 5 and however many multiple workers you have running at once, so maybe 5 to 50 meg of the file. But all of the rest of the thing you won't actually lose. Like, if you're at 50% of the way through a 1 terabyte upload, you should be roughly 50% of the way through when you resume. And all the encryption happens before any data is sent off your machine. If you were inclined to look at how the FileSender works with web workers to do uploads, this is a brief overview of what happens behind the scenes in the code. In retrospect, maybe looking at the code is having seen other talks here, it might be not what people are looking to hear. I can gloss over it, or I can just do it, and I'll probably just do it anyway. And anyway, so yes, when you do the on-click, it basically selects between 3 different ways of uploading. It may seem strange that there's 3 or 4 ways to do uploads, but then this also has to cater for people who don't have modern web browsers. So if you don't have a modern web browser, then you're back to using a web form, and then you may have to upload the whole file in one go, using a post or something like that, because the web browser doesn't support recent features. I'm inclined probably to chop that out at some point, because trying to support web browsers that can't do recent sorts of things, like if your web browser is more than 2 or 3 years old, then maybe you shouldn't be using it. Which is, I'm inclined to think that, but also some people at research institutes that use FileSender, they're using surprisingly old web browsers. So versions that are, shall we say, very insecure, where you can, using non-nefarious JavaScript, actually crash the browser, and people are using that as their daily browser. But then again, if I do that, then there's going to be people complaining that old browsers no longer work with it. So there's currently 3 or 4 different ways to upload. And the FileSender one, basically you create a worker and then you send a message to it to start doing its stuff. Once it gets that message, it sends a message back to the controlling thread requesting a job. And the controlling thread then allocates a job. And I'm pretty sure I've got a slide on that, which is the main interesting part, and sends the job off. Yeah, so when you're allocating a job, you try and keep a worker on the same file. You can, in the configuration, say you want to have 5 different workers, and you can nominate that they'll work over multiple files at once. So again, it's a preference whether you want them all on the one file or over multiple at once. And it basically just keeps doling up chunks until all of the chunks have been sent, and monitoring for errors, and then telling the thing to restart if there was an error. And at the whole higher level, there's basically by the way, this whole upload has timed out, and this is what's involved in the sending of a chunk, with all of the error messaging involved. It may be better for me not to go into excruciating detail on the code. If people want to see excruciating detail, then by all means, come and see me, and you'll no longer want to hear about the excruciating detail. The security has a mixed authentication model. You either have people who are authenticated with your SAML server, or they're allowed to invite guests if you allow them, so that basically a guest can come in and you don't really know much about them, but they can be locked down, and they're locked down in the configuration so that if a guest comes in, they're only allowed to upload files to the person who invited them. So you can't you can say to the server, I don't really want to allow these 100 people to invite guests who can then send files to anyone or get links to those files and send them around. I wouldn't mind them having guests, but if they do have a guest, they should be the only one who get the files that they upload. So if the other person goes rogue and uploads miscellaneous sort of undesirable stuff, then yeah, you don't get used as a conduit for that sort of thing. At the moment, there's a AES 256 CBC type algorithm, which is done encrypted on the client browser and decrypted on the client browser. There is talk of moving to a counter mode encryption with the AEAD, which basically having cryptographically bound data and also authentication code. So rather than having CBC stuff where there's the potential, like there's no HMAC involved, you have absolute assurance that if it decrypts, you have the same file that was uploaded. So you have, and also the cryptographic binding of data. So if you have recipients or a message or a subject or something, or some ID on the server side, that all gets bound into the encryption. So if someone comes in later and doesn't have access to all of that information from the server and doesn't have the same password and doesn't have all of that bound information, then they can't really decrypt it anyway. So the second batch of moderately low-level code is using the Web Crypto API for the current encryption. So at the moment, basically, generate key is called, and then the encrypt on each block with an IV. The generate key is probably the more interesting or less straightforward thing there. Yeah, the IV being 16 bytes of random data used in a when the user types in a key, there's basically a nominated amount of hashing that happens on the key, so that depending on when you're generating a key from a passphrase for AES, you have to hash a certain number of times, and if you hash more times, then you have a perception of a longer level of security of the encrypted file. Because if an attacker wants to try and guess your password, if you're hashing 1,000,000 times, every time they guess a password, they have to put the password in, hash it 1,000,000 times, and then try that as the key. The flip side is if you hash for 1,000,000 times, it might take your machine 2 seconds to do that, which means if someone's trying to guess, they have to pay a 2-second penalty for each attempt. But at the same time, your web browser, like when you're uploading, you'll have to basically wait for 2 seconds for it to hash your passphrase to generate the key. So it's a bit of a trade-off in that the longer you actually want to expect privacy, the longer you have to be expecting to wait to actually hash the key. One of the things that I'm looking to add here is instead of, and it's again, it comes down to a policy decision as to whether or not this should be the default or the default should still be for passphrases. I'm thinking maybe the default should be whatever the system administrator configures. But the idea is to have, in an ideal world, the user doesn't type a passphrase in. The key is basically an automatically generated 256-bit random string. So you get the most security out of it. You don't have to hash anything anymore because it's sort of pointless to hash a random key that you're generating. And then you display that to the user and say, by the way, if you'd like to use a passphrase, you can go that way if you like. But this is actually a more secure way of encrypting the file. So it depends on, again, if you want to have the security, you need to have a large random key, which people who are typing in keys may type in 8 characters or something and think this is random. But to a computer, it's probably not. This is sort of an updated generation of keys, which moved to a two-phase thing where the first key is actually imported from the password, a number of hashes is run on that, and then that key is then used to derive a key that can do encryption and decryption with AES 256. So the current encryption uses the hashing rounds on a generated or user-supplied passphrase, and in the future we'd like to sort of bind document IDs and any information that is relating to a transfer that we can to that transfer to actually help in generating or locking in that key is used. So if you then turn around and say, I'd like to have my key be, kitten, but then you do another transfer and you'd say, I'd still like to use the key kitten. It doesn't really matter, because if the other person if you send that first transfer to someone and they say, aha, maybe you're going to use the same key again, and they happen to get a link to the second file, it won't decrypt, because the second file will have a different document ID. There'll be different bound data. So even if you keep reusing the same key, every time you do a transfer, it'll be cryptographically different. So it's sort of trying to, I suppose the thing is trying to help people be more secure than they would otherwise be, which is why I like this idea of actually using the random generated key. And the trick there is displaying it to the user in a way that's sort of convenient. Like if you say, you've got a 256-bit key, we'll display that as a hash key or something. People are not really going to like this ultra-long hash string, but if you sort of display it in some more human-readable and relatable sort of format, like starts with words or things like that, or as a QR code or something, you can take a photo with the QR code, or however you're going to transfer that around. I'm still wrapping my head around the GCM stuff. Luckily, there is for FileSender, there's a FileSender board who are sort of directing how things are happening. And as part there are people who are dedicated crypto people who are advising. So it's not that I need to. And GCM, as put forward by NIST, is probably not going to work here, because you also need to be able to encrypt chunks in random orders. And if you're resuming, you need to be able to say, I'm halfway through. Yeah, I can't really say I'm halfway through and I'd like to have all of my encryption set up exactly how it was before the user closed the browser last night. So you need to be able to sort of react to and continue an upload, because you don't want functionality to be sacrificed. The user's not going to be happy if they've uploaded for 24 hours, got 70% of the file done, and the browser crashes, and they go back and it says, oh, it's more secure for you to upload that 70% again. There's probably going to be words that you don't want to hear. So GCM operation, I'm not sure, are there any encryption, crypto sort of people in the audience? Possibly. So this is currently my reasonable understanding of how things go. So the key is based on the multiply hashed password, or if you're generating with just pure entropy, you can just import a key with entropy and not have to hash it, which is a huge plus, and also far, far more secure than any password that a person would put forward. Create the IV with again, a series of 96 bits of random stuff and a 32-bit counter, because you only actually want an IV of 128 bits. Combine those two together, encrypt. This is the only part that I'm still a little bit, I will be clarifying this encrypt operation on plaintext equal of counter. So because some documents just say, you just run an encryption level, what you're actually doing with the IV. The key and the IV are the core to this, because the entropy and the counter that are in the IV are what is generating the blob that you're then just XORing with the plaintext. So it falls back to being like a Vernam one-time pad, and the whole security of it is the fact that the encryption of AES on the counter and the entropy that you're providing is random enough that the person can't backtrack from that. So it always, if you're doing one-time pad stuff, it always relies on the fact that people can't work out the thing that you're using as your one-time pad. And again, the plus side is that this is probably going to be audited by people who are encryption experts, and I'm happy to do the coding, I'm happy to verify it, I'm happy to say, yes, this works, but it's also better for people who are using it to say, it's not just Ben saying this works, it's people who are doing encryption sort of all the time who are saying, yes, this is working and is secure. Yes, away from encryption. It has internationalization. There's internationalization substitutions in things. We use PO editor for translations. There's currently translations in Dutch, translations obviously in sort of multiple versions of English, however different Australian is from the US, but we need our own version, but anyway. But yes, there's Russian translations, German, and the PO editor interface is sort of just a web front end, and you get, these are the tokens, this is the English version of it, and it's reasonably straightforward if you're not interested in loading files and actually editing PO files directly. And a bit of logistics behind adding and modifying new terms and dealing with PO editor, which I'm inclined to skip over. The future directions, there's a planned UI refresh because the user interface you saw didn't sort of have massive bells and whistles and use Bootstrap or look like Twitter or Facebook or anything like that, but it is a little bit of a dated UI, I'll give it that. So that's sort of on the table to come to a more modern look, probably hopefully more themable as well, or easier to theme. It was mentioned, and I sort of had to play around in a few of the mobile scenes. Initially there was a few people saying that an app would be nice, and I thought if you're sending a 1 terabyte file, if you have a mobile device that has a terabyte of storage, you've done well. But on the flip side, if you're sort of taking 5 or 10 photos on an iPad and they're reasonably high resolution, you probably can't email the 10 photos to someone because it'll bounce. So being able to tap, send to or share and then share it through FileSender and actually have the links in your web browser. And also permissions. A lot of mobile devices will say, if you're trying to upload in a web browser, they'll say, your photo app took that, and I won't allow your web browser to see it. So if you could share it through some app that you've installed that knows how to authenticate to FileSender and it makes it a one-tap or a two-tap sort of experience, that would be a plus. I wouldn't mind a feature which may be useful to others is integration with endpoints. So if you're uploading a video file and you want to, you can actually have it mirrored on YouTube or have it sent to a video service or mirrored to a picture place of your choosing. So then you don't have to worry about interacting with other websites. An update, and also cited one of the GCM relevant NIST standards for the updated to the encryption. Docker images are sort of planned. There are some at the moment, so you can spin up 3 Docker images and have the PHP happen. The one thing I'm not entirely sure of is how MySQL or Postgres work in a Docker image, but that would be nice to be able to sort of just have, here's a collection of 3 things I want FileSender, I'll just start these 3 things up, and you sort of pick and choose what authentication you want to have and not have to go through the installation, which can be, it's not incredibly difficult, but it's not as easy as starting 3 Docker images. I've got some information on how to change the SAML so you can have a really low-end authentication. So you have, I'd like to have only 10 users, and I want these 10 users to have these passwords, and I don't really want to have to set up a Radius server or some heavyweight authentication service just to have that happen. But having something in between, so you can just say I've got an Active Directory already. We're using that. If you can point at that and then do your magic with that, rather than having to play around with SAML configs and just sort of have that work. One of the other things was mentioned by one of the system admins was session clone. So if a user's having an issue, they can sort of click a button, and if the administrator happens to be there, they can actually bring the whole session that the user has, like basically have a clone of the web browser in their web browser to see what's happening. So if there were errors or things like that, they could bring up basically see what the user sees and try to help them with what's happening. Especially if they've tried to upload a few times and it's failed, rather than just saying, I've tried and it's failed, and here's like a fragment of the last error. Since that was mentioned, there is now when things really go wrong, it pops up and says, this upload has failed, I've tried it 10 times, would you like to send some information from your browser through to the system administrator to help with that? And again, this sort of plays in with the trying to be GDPR compliant by default, in that basically it's popping up and asking for consent to send through log information that your browser has for the failed thing. And if you want to, you can just sort of say no, like, I've tried it, didn't work, don't care. On the other hand, you might say, well, it's a research file, I've tried it, didn't work, I'd like to do it next week. So, send the log through. Possibly too, but, I'd probably put it last as maybe running the whole thing in the cloud. But there are some people who want to run the storage in the cloud because they're getting reasonable deals from the storage providers. So that's why FileSender can turn around and sort of store data in Azure or in Amazon. And obviously they can run their databases and probably run PHP, so you could run the whole service there if you wanted to, but it's possible. But alrighty, so hopefully my guiding through code stuff and talking about crypto didn't send everyone immediately to sleep. But it was only when I got halfway through the code thing I thought, this seems like a terrible mistake. But anyway.
Using crypto.
Well, the crypto thing, I think it's interesting because a lot of people sort of say, oh, it does encryption, and then they say it does encryption on the client side. But unless you really start getting into the details and know, like, this is what's happening, this is why it's happening, this is why it's secure, saying it's encrypted is one thing, but actually meaning it and meaning that you want it to be secure is the, I think probably the big impression, like, and not just me saying, but also having people who are security people audit it and say, yes, this is not, I mean, security is always a process. It's not sort of, this is tick, this is not, but,
Not believing in security in encryption is similar to saying that using encryption is not going to make it secure.
Well, I mean, yeah.
Apart from that.
Yeah, apart from that, yeah. There's always going to be ways of attacking every system, so.
Are you heard PHP, MySQL? Are there any other dependencies on the server side to run the server?
Apache or NGIX.
Yeah, okay, but just basic PHP after.
Yeah, nothing really. I mean, the SAML thing, this is really the sticking point. The SAML thing needs somewhere to authenticate to. Or you hack the config file and sort of say, I'd like to have 5 users or, So the in-between thing, if anyone has suggestions for small offices where this would be a really useful, like, whether or not authenticating with PAM would be handy, what would be the most useful for that sort of environment?
I don't know if you can hand off the authentication to an Apache authentication module, because then you already have like a load of those things already.
Okay, well this is great because that's something that I'm happy to look into, because that's, like, if you have this big server to do authentication, then it's great, but I'd like to sort of have that, and if it can do that, then that's certainly a config file that I'd be happy to make. Or a code that I can hack to make it happen. Yeah.
Okay, we have to wrap it up.
Okay.
So thank you very much. Famous stroopwafels here.
Ah, excellent.
Thank you very much.
Thank you.